And is the inaugural director, that is the first director of the Alexander Grass Humanities Institute at the Johns Hopkins University. Previously, he was vice dean for graduate education of the Krieger School of Arts and Sciences at Johns Hopkins and was chair of the Department of German and Romance Languages and Literatures for 6 years. He's the author, editor, and translator of more than a dozen books on such topics as the relationship between literature and philosophy, religion and politics, and science and the humanities. His many books include How the World Became a Stage, 2003, Perversity and Ethics, 2006, A Wrinkle in History, 2007, The Philosopher's Desire, 2007, The Theater of Truth, 2010, In Defense of Religious Moderation, 2011, The Man Who Invented Fiction, How Cervantes Ushered in the Modern World, 2016, Medialogies, Reading Reality in the Age of Inflationary Media, 2017, and the Splintering of the American Mind, Identity, Politics, Inequality, and Community on Today's College Campuses, 2018. This is somebody who, being a director of Humanities Institute, is clearly always thinking about the humanities and always thinking about the humanities, public-facing humanities as well, and thinking about our time and the issues that concern us today. So he's a perfect person for Dante. And in that regard, I thought I would point out that in addition to his scholarly work, so his humanities in other venues, he contributes frequently to the New York Times, that's the paper of this town, and other periodicals. And but I'd like to read some of the titles of, There's No Such Thing as Reality and It's a Good Thing Too, Los Angeles Review of Books. Letter from Austria, Europe's Tolerant Society Backfiring, New York Times. What are we talking about when we talk about zombies? The Philosophical Salon. Dreamboat Vampires and Zombie Capitalists, New York Times. On Borges, Particles and the Paradox of the Perceived, New York Times. Can Neuroscience Challenge Roe v. Wade? The New York Times. Bodies in Motion and Exchange, the New York Times. Quixote, Colbert, and the Reality of Fiction, the New York, that was Colbert, right, and not Colbert, yeah. The Revenge of the Novel, Foreign Policy. So this is someone who writes for many publics. Why is he here? Well, now I knew, okay, so there's somebody at Johns Hopkins named William Egginton. But for years, I had been reading this article called On Dante, Hyperspheres, and the Curvature of the Medieval Cosmos by William Egginton. So when I was at Johns Hopkins, I said, are you the same? Are you the same William Egginton who's written about cosmology in Dante? Because you seem to do so many other things. In fact, actually, he's a Hispanist. And he said, yeah, that's me. I wrote that thing. And it's an article that I've given out to students of my Dante class when I want to blow their mind for many years. And so the last time I saw Bill, I said, well, would you like to come up and talk about Dante and cosmology? So he's revisiting something. This kind of is cognate with, I think, what I wanted to say about that article. It's something from his past, but it's towards the future. And so this article on Dante, Hyperspheres, and the Curvature of the Medieval Cosmos, which was published in the Journal of the History of Ideas, which is published by the University of Pennsylvania in 1999, he starts by noting that Stanford astrophysicist Robert Osserman, when trying to tell the story of how we got to understand the cosmos as we do today, felt the need to explain the hypersphere. Some of you may know what that is. Maybe after today we'll all know, which, as I understand it, is a sphere in 4 dimensions, or maybe a sphere whose surface extends in 3 dimensions. And so Robert Osserman had to turn to Dante to explain it. How to solve, and he says it's a way to solve the problem, perhaps you know it's a problem, of the edge of the universe, which was not proposed until the 19th century. Is there an edge to the universe? While Osserman had no explanation for how Dante could have gotten to this place so far ahead of his time, Egginton argued that Dante knew things that after the scientific revolution we forgot. or had a habit of mind that lent itself to the way of seeing the universe that turns out to be extremely modern. It is an example of how revisiting the past has always been a source of innovation in the present. What Egginton said was, "When we tell a story leading to the present, the mentality of Newton's age is the rock we stand on. When we spread out those presuppositions like cards on a table, we see how medieval we are and how much we have forgotten." So I give you Bill Egginton.
Thank you, Allison. Thank you, Casa Italiana. Grazie, Stefano, and everyone involved. Great to be here. And wow, I mean, it's a rainy Monday night, and this room fills up for Dante and Cosmology. What are we doing wrong in Baltimore? Maybe it's just not having 8 million people. That could make the difference. All right, so with the aid of glasses, take a look at some of my notes here. Let's get into this. It's an exciting story. Allison gave a wonderful, wonderful introduction simply because you kind of queued up some of those issues that I want to dip into and then move around as well. So maybe some of you will recognize this face, maybe not, but I'll let you know who it is in a moment. Let's begin with a difficult thought. This thought comes to us from the Middle Ages, when they thought many difficult things. But they also thought many things that were just wrong. Some of the difficult things they thought not only were not wrong, however, they were right in ways that few people at the time could have imagined. Many of you know the writer and scholar C.S. Lewis. This is who we're seeing right now. Most of you may know him as the author of some very nice allegories of Christian faith that you read as children and have perhaps more recently seen in the movies. Others will recognize him as an expert on medieval English literature. C.S. Lewis, during the course of his lectures on medieval literature at Oxford University in the 1940s, would often ask his students to join him in walking outside at night and looking out at the starry skies. And this is what he said: "Whatever else a modern feels when he looks at the night sky," he would tell them, "he certainly feels that he is looking out, like one looking out from the saloon entrance onto the dark Atlantic or from the lighted porch upon dark and lonely moors. But if you accepted the medieval model, you would feel like one looking in." This, then, is my first difficult thought for you. How do you look out at the night sky, or at any sky for that matter, and imagine not that you're looking out, but that you're looking in? To do this, we might begin by imagining that the surface of the earth we're standing on is not flat, but curved. Oh, we've already managed to do that, you say. And it's a good thing, too, because it turns out to be true. But now imagine not that it is convexly curved away from the soles of our feet, but concavely, such that way out there, beyond any visible horizon, the Earth's surface is sloping up and eventually encompassing everything we see. In this newly inverted cosmos, no matter where we stand on the surface of the Earth, we could stare straight up and be pointing at the exact same point. Furthermore, we could imagine that way beyond that point, about the same distance away, there could be someone else, also standing on the same surface, staring back at us. It's a strange idea, but now that we've managed to think it, it sounds something more like out of science fiction, I would say, than medieval literature. But C.S. Lewis got it right out of the greatest medieval writer of them all, Dante Alighieri. Here's what Lewis says. "But I have already hinted," this is quoting from Lewis, and then I'm going to get into the text that you have in front of you. "I have already hinted that the intelligible universe reverses it all. There the earth is the rim, the outside edge where being fades away on the border of non-entity. A few astonishing lines from the Paradiso stamp this on the mind forever. 9 concentric rings of light revolve around that point, and that which is smallest and nearest to it has the swiftest movement. The universe is thus, when our minds are sufficiently freed from the senses, turned inside out. So, let's look at the canto in question. This is Canto 27 of Paradiso, and I've excerpted here lines 79 through 120. I think it's worth the time. It's just going to be 3 or maybe 4 pages of verse, just to go through it quickly. And you have, those of you who are fluent in medieval Tuscan dialect can read to the left. I won't venture that. I might have Eugenio Ruffini read it out loud for us, but in the interest of time, we'll work with the translation, which is also sufficiently old-fashioned. I had wanted a more modern translation, but I also didn't want to go to the trouble of typing it all out, so I took something that was available from the 19th century. Thereat the lady, who had seen that freed I was from gazing up, said, "Lower now thine eyes, and see how far thou hast revolved." So this is Dante and Beatrice stepping out, and I'll explain that in a moment again, because it's sufficiently complicated to be worth spending some time with. And he's able to look down in one direction and up in the other, and see where he came from and where he's going. I saw that since the hour when I had first looked downward, I had moved through all the arc. The first of climates makes from mid to end. Past Cadiz, hence Ulysses' insane track. I saw and nearly to the seashore, where Europa made herself so sweet a load. And of this little threshing floor much more would have been shown, but the sun was circling beneath my feet, a sign or more removed. We're going to go through the whole, and then I'm going to focus in on some lines. And my enamored mind, which in my lady always takes pleasure, more than ever now was burning to restore mine eyes to her. And if or art or nature e'er made baits in human flesh or in its painted forms to catch men's eyes and capture thus their minds, they altogether would seem naught compared to that divine delight which on me shone. When to her smiling face I turned around, the virtue, therefore, which that look vouchsafed, removed me from fair Leda's lovely nest, and urged me on to the swiftest heaven. Its nearest and most exalted parts are all so uniform, I cannot tell which Beatrice selected as my place. But she who saw my wish began to speak, and smiled so happily that God appeared to be rejoicing in her countenance. She says, "The nature of the world which quiet holds the center, and around it moves the rest, beginneth here as from its starting point, and this heaven hath no other where than in the mind divine, where kindled is the love which turns it, and the power itself rains down." One circle's light and love encircled it, as it the other heavens. And he alone this precinct understands who girdeth it. Its motion is not measured by another, but all the others are by this as 10 is measured by half and by its fifth. And now how time in such a flower pot can have its hidden roots, and in the rest its leaves, can hereafter be manifest to thee. The lines from Dante's Paradiso that I've just quoted to you are indeed astonishing. Having journeyed in a first book down through the 9 concentric circles of hell to reach the center of the earth, the narrator, our pilgrim, has from there ascended the mountain of purgatory and finally reached, with his guide, Beatrice, the outer rim of the corruptible cosmos, known to the Aristotelian philosophers of the Middle Ages as the prima mobile, or prime mover. Upon stepping with her from the prima mobile into the Imperium sphere, Dante makes the comment that, or Pilgrim makes it, quote, "Its parts were all so equally alive and excellent that I cannot say which place Beatrice selected for my entry. From this new vantage, he looks further up, that is, away from where he has come, and sees this, quote, I saw a point that sent forth so acute a light that anyone who faced the force with which it blazed would have to shut his eyes, and any star that seen from earth would seem to be the smallest. Set aside that point, as star conjoined with star would seem a moon. Around that point a ring of fire wheeled, a ring perhaps as far from that point as a halo from the star that colors it, when mist that forms the halo is most thick. It wheeled so quickly that it would outstrip the motion that most swiftly girds the world. That ring was circled by a second ring, the second by a third, the third by a fourth, fourth by a fifth, and the fifth ring by a sixth. So in Alison's introduction, she mentioned a book by Robert Osserman, who was, in fact, at the time that I was at Stanford, around the same time that Alison was, many, many years ago, was a theoretical physicist in that department. And he published a beautiful little book that, in fact, sent me on the trail of this mystery, The Poetry of the Universe. Let me quote from that book, and I'll put the quote up there. In the Divine Comedy, Dante describes the universe as consisting of two parts. One part has its center at the earth, surrounded by larger and larger spheres on which move the moon, the sun, successive planets, and the fixed stars. The outer sphere bounding all the visible universe is called the prima mobile. What lies beyond this is the Imperium, which Dante pictures as another sphere, with various orders of angels circling on concentric spheres about a center where a blinding point of light radiates with almost blinding intensity. And here's a famous rendition of that moment of looking up at the circles of concentric angels and fire, rings of fire, down to a point of blinding intensity. So what's extraordinary about this, and I'll just quickly put this in a parenthetical, and it's very, very hard to imagine. Well, it can't really be imagined. You have to sort of talk your way around it, which is what Dante is doing in this passageway. But he makes the point that Beatrice could have selected any point, and it would have been the same. So it didn't really matter what direction they moved out from the center, because ultimately, no matter what direction you move out, and you keep on going in this hyperspherical structure, as you go out and out and out, before you know it, you're going in and in and in, and you're going to end up at the same point on the other side of the hypersphere. And it doesn't matter what direction you select to go out. That's the point. And somehow Dante came up with this structure for which there wasn't the mathematics at the time. And Osserman's question, and what I sought to address 20 years ago, and what continues to fascinate me, is how Dante could have come up with that structure, even if he didn't have the mathematics for it. Dante's description of this absolute center as the origin of all movement and force in the universe is indeed, as Osserman puts it, quote, an eerie likeness of what he terms, Osserman terms, the retroverse. The retroverse is what I just described, through which an imagined journey would require ascending, right, all the way from the central point of the earth, until at some moment, the traveler would find him or herself descending towards the fixed point, or the other way around. But it would be another fixed point. The origin of the universe, perhaps. Naturally, we must stress the imaginary nature of such a journey, since our traveler would have to be outside of space as well as time in order to, quote-unquote, see the convergence of space-time into a single, infinitely dense point. The fact that Dante imagined something so similar is extraordinary. But does it make sense to attribute the similarity to anything more than what Osserman calls, quote, a rare confluence of the poetic and mathematical imagination? It's a reasonable assumption. Well, let's see. What I did in that work, and what's led me to today, was to go back and do what you could call a genealogy of the theories of space and place that were predominant and that would have given Dante a kind of theoretical basis on which to make his model. So it all starts with a problem in Book 4 of Aristotle's Physics. And that's what I have up here on the left side. According to Book 4 of the Physics, the definition of a thing's place was, quote, the innermost motionless surface of the containing body in direct contact with the contained body. And you should immediately think that this might pose a problem if your contained body isn't contained by anything, right? And this led to constant conundrums in the Middle Ages, which is along the lines of questions like, can God move the universe? Well, of course God can move the universe. But wait a minute, if the universe doesn't have an outside, if it is everything, it doesn't have a container. And if it doesn't have a container, according to Aristotle, you can't move it because there's no definition of motion that comes from that. Now, with usual ingenuity of the Middle Ages, many great solutions were proposed. So let's take a look at some of them. All right. Avicenna So this is the earliest of the thinkers I'm looking at here. He argued that a sphere need not be in a place to move, but it can move upon itself. Right? It's the center. So it's having a motion not relative to a container, but to a center point. Avem for him, the celestial spheres have no need whatsoever to be lodged in such a way. Neither are they lodged by the outside, and this is a really ingenious model, but they're lodged by the inside. Each one of them has a place in the convex surface of the sphere that encloses and round which it turns. So here think a little bit of that inverted plate model of the Earth that I showed you as we started to think with C.S. Lewis about what it would mean to look out in space and be looking inside at the same time. Averroes countered that the outermost sphere had a place per accidens, so sort of secondary or accidentally to the primary or to the essential, based on its center, which was a place per essence. So the essential place was the center, and the outer place, therefore, because the essential place had a center, had an outside. Aquinas disagreed. The rational place of whatever container comes, therefore, from the first container, the first lodging place, that is heaven, he said. And this whole problem, not the last, not Aquinas, but he was mostly influenced, I think, here by this series of thoughts running through Aquinas, is what Dante is referring to when he, and when others can see in his work, as solving, right? When he writes, quote, and here, this is what we quoted in reading those passages, this heaven has no other where than in the divine mind or in God's mind. Right? That's the center, that's the place. The place is the actual mind of God, and everything else can find and hence have motion, because in this case it can move around or anchored by the mind of God. So rather than as a mere coincidence, perhaps we should try to understand this convergence, as Osserman said, between poetic and mathematical genius, as the indication of a deep-seated epistemological difference, so a difference in the way we see and understand the world, right, between Dante's world and our own, and as a sign of some possibility of knowledge that could still imagine a world where space was curved and where the universe could be at once finite and boundless. For what indeed accounts for the bizarrely detailed language in which Dante describes this structure, if not an entirely different way of imagining space and what space can be? So, another figure you might not recognize, but I'm about to tell you who this is. 19th century, an inventor of a form of mathematics that in fact allowed cosmology and physics to catch up with this idea and to do so in a rigorously mathematical language. For many centuries, no one had the mathematics to adequately describe such a space. But in the 19th century, a brilliant mathematician by the name of Georg Riemann decided to experiment with spaces that would not conform to the axioms of geometry that had stood the test of all the time that had passed since Euclid formulated them. His so-called non-Euclidean geometry, or non-Euclidean spaces, became instrumental for Albert Einstein's understanding of what the curvature of space-time is. Riemann's model resolved that paradox, which is rooted in the assumption that the universe is flat, or Euclidean. If instead it is positively curved in Riemannian, then it can be finite in extent and still not have any edge or boundary. That's the problem that we referred to as the age-old problem of the edge of the universe. And the idea there is in that hypersphere, there is no edge. The universe can be self-contained, can be total, there's no border or edge, you're not going to fall off the edge anywhere. And yet, it is without an edge, and still it's boundless. In Riemann's model, every part of the universe looks like every other part, as far as shapes and measurements go. It's a smooth curve, one would say. So, today, many years later, contemporary cosmologists consider the four-dimensional space-time of the cosmos to, in fact, approximate the shape of Dante's universe. And we're going to explain a little bit the evidence on which that assertion is based. This view emerged from the cosmic microwave background radiation maps of the universe made in the 1960s by Arno Penzias and Robert Wilson, here pictured, which turned the tide of scientific opinion in favor of the Big Bang theory and won them the Nobel Prize. And here is their famous picture, beautifully illustrated or colored at this point, of the cosmic background radiation. It's a map of the universe, essentially, a map of the universe looking outward. And what is so notable about it is, in fact, the relative the relative smoothness of the spaces. When you see the different changes in color, you notice that these are, generally speaking, smoothly spread around the universe. The fact that there is clumping at all accounts for the formation of galaxies, but other than that, the assumption continues to be that the general laws of physics that govern from our perspective, infinitely widely spread apart portions of the universe are the same. So that Riemannian smooth space of the curvature is the same. The idea here is it doesn't matter what direction you look out. You look out 14.7 billion light years away, your vision is closing in on the same space, an original point, a singularity, theoretically, 14.7 billion light years away, which is the beginning of space and time, remarkably similar to what Dante is doing in his archaeology or architecture of the cosmos. So according to this view, the point occupied by any observer would be the center of one end of the hypersphere, let's call it hell for fun, and the singularity located at the origin of space-time would lie at the other end. In our universe, while no one can venture very far in that direction, the light and other forms of radiation that travel the furthest and longest to get to us have their origin there. And here's the doozy. No matter what direction we train our telescopes, if we look out far enough, we're looking at the same spot. Let me start to encapsulate how remarkably unnew, if you will, some of the most shocking discoveries of modern physics can sometimes be. I could have gone several different places for this, but I'm going to quote from Sean Carroll's most recent book. He's a Caltech theoretical physicist, and it's a quite wonderful book called Something Deeply Hidden from 2019. He says, if the system is the universe as a whole, we are all inside it. There's no external observer to whom we can appeal. Years later, he's telling a story about this, Stephen Hawking and others would study quantum cosmology to discuss how a self-contained universe could have an earliest moment in time. How can a self-contained universe begin in time, was the question. The years earlier he's referring to is years earlier in the 20th century march of physics. He wasn't thinking of the year 400 CE, when we can find in Augustine's Confessions the following sentence. If there was no time before the creation of heaven and earth, the question, what were you, God, doing then, is meaningless. For when there was no time, there was no then. It's not that God didn't exist, it's that then didn't exist. And to understand that in spatial temporal terms, you have to be thinking already in some way in the form of a three-sphere. Here, again, the absolute character of space and time becomes, for Newton, as for the modern age, the condition of possibility of knowledge itself, the foundational table upon which the organization of things can be mapped out. This is the idea that we still have stuck in our minds today about how to think about space and time. Flat, infinitely extended space. That's what we do our mathematics in. When we think about shapes, we think about it in that way. While Dante made no pretension that there even was such a thing as a fourth dimension, Aristotle's negation of such a possibility in the physics was never questioned. The universe he described was, from the vantage informed by Riemannian mathematics, in fact, four-dimensional. It was four-dimensional because the basic notion of space available to the Middle Ages did not exclude curvature. That exclusion, and perhaps our own difficulty in imagining curved space, is a legacy of the modern age. Dante conceived the cosmos as a form in multidimensional curved space-time because his age had not yet taught him the impossibility of doing so. Where did he come from? You're going to find out now. As we have about enough time to think one more difficult thing today, I'd like to move on to the late 18th century, to the work of the great German philosopher Immanuel Kant. One advantage to talking about Kant in the context of a very short lecture is that one doesn't need to spend a lot of time on his biography. Kant did very little. In fact, He never left his hometown of Königsberg, Prussia, from the day he was born in 1724 to the day he died almost 80 years later. What he did do, quite a lot in fact, was think. Towards the end of his life, he wrote quite a lot of that thinking down. And one of the books he wrote became one of the most influential books of modern philosophy. It was called The Critique of Pure Reason. And here is one of the very difficult thoughts that he put into that book. It's called The Antinomy of Reason, and this is just the second part. It comes in 4 parts. But I'm going to explain to you why I think this is interesting and what it has to do with Dante and cosmology. The first part, every composite substance in the world consists of simple parts, and nothing exists anywhere except the simple, or what is composed of simples. The second half, no composite thing in the world consists of simple parts, and nowhere in it does there exist anything simple. 2 straightforward, logical possibilities. The problem is I'll explain this in a moment when we get to a modern cosmologist who's doing something very interesting with it. The important thing to grasp is that these opposing statements are in fact part of a single thought, which is the second part of what Kant calls the antinomy of pure reason. The trick of the antinomies, or of the parts of the antinomy, is that each side appears irrefutable. If you read it on its own, yes, that makes total sense. And yet, each would seem to refute the other. In the case of the second antinomy, the outcome is this. If every simple substance is further divisible, then there is ultimately no substance, and hence no existence whatsoever. But if we do eventually find an indivisible substance, it must occupy a space. And space means extension, and extension means divisibility, etc. Kant brings up this tricky problem in order to prove an idea he has about the world and the way we perceive it. Namely, that there is a fundamental difference between how we perceive the world and how the world is in itself. I have, in fact, no basis for assuming, if I'm Kant, or, in fact, anyone following his arguments, that the infinite divisibility of space has any applicability whatsoever to the world as it is in itself. It is a characteristic of how I, as a human, observing creature, intuit the world, namely, in space and time, and it's not a characteristic of the world itself. A last little portrait. Now, Kant considers himself a scientist, but he certainly had no access to either the observations or the mathematics that sustain today's remarkable achievements in cosmology. That makes it all the more surprising that in the words of the string theorist and popular writer Brian Greene, quote, many of today's leading physicists suspect that space and time, although pervasive, may not be truly fundamental, and that, quote, the properties of space and time may also emerge from the collective behavior of some other more fundamental constituents, which we've yet to identify. Greene goes on to describe space-time in the view of current theory as possibly, quote, an illusion, masking an even more elemental description of the universe, one that is spaceless and timeless. Quote, the illusion, and listen to the aesthetic analogies he uses to describe this remarkable idea. The illusion then would be of our own making. The erroneous belief that the deepest understanding of the cosmos would bring space and time into the sharpest possible view. Just as the hardness of a cannonball, the smell of the rose, and the speed of the cheetah disappear when you examine matter at the atomic and subatomic level, space and time may similarly dissolve when scrutinized with the most fundamental formulation of nature's law. Greene goes on to cite research based on the geometry of black holes that suggests that space itself may have a minimum size, the so-called Planck square, measuring about 10 to the negative 66 meters. It's important to grasp that with this example, that it's not simply a question of modern physics having solved Kant's antinomy with the new information that, yes, in fact, there is a fundamental unit of matter that we can't divide. Rather, the point is that space itself, according to this theory, is no longer divisible beyond a certain point. Because the very notion of spatial division simply does not apply to measurements smaller than a Planck square. This would not imply that more fundamental and smaller processes were not at work. Instead, the idea is that whatever underlies space and time is not itself conceivable in spatio-temporal terms. The real, whatever it is not of the same substance as space and time. This is, remarkably, exactly what Kant was trying to say 200 years ago. This evening, I've asked you to think two very different, difficult things. Let's call them thing one and thing two. Is there anything at all that these two thoughts have in common? Recall that toward the end of thing one, I mentioned how contemporary cosmology concluded that at least one center of a spatio-temporal hypersphere coincided with an observer. Thing two, it turns out, also has implications for the role of the observer. To quote Green once more, quote, "Looking for familiar space-time in the deepest laws of nature may be like trying to take in Beethoven's Ninth Symphony solely note by note, or one of Monet's haystack paintings solely brushstroke by single brushstroke. Like these masterworks of human expression, nature's space-time whole may be so different from its parts that nothing resembling it exists at the most fundamental levels." If we think a bit more about that idea, we are led to the possibility that the very idea of a particular subjective observer, or a decider, or a thinker, so essential to poetry, to philosophy, to art, might have a very central role to play in the basic objective understanding of the world that we call science. Not only have the geniuses responsible for discovering so much about our world more often than not been men and women of great learning in all of the above-mentioned fields, like Dante, it may also be the case that discovering things about the world is inextricably bound to the way we think about it. Thank you very much. Be very happy to discuss, take questions. Yeah. Yes, in front.
How did that guy ever get to the idea that
Which guy are we talking about?
Dante, that
Thing one or thing two?
brass young man that you showed,
Oh, Brian Greene?
yeah.
Okay.
How did he ever get to this point that space and time were not fundamental? And two, if I believe that, what would I do after I got up from this chair?
I think that, starting with the second question, I don't think we need to change the way that we're going about the world if it turns out that, in fact, space and time aren't fundamental. Kant is interesting to read on that regard, but for entirely different reasons, because he, in fact, builds up a whole system of what he calls practical reason, based on the idea that we need to be really careful about assuming that our intuitions, the way we think about the world in space and time, in fact, can be projected onto reality itself. Greene doesn't go there. The first part of your question is very interesting, and there, if it does interest you, I would just recommend that you read, for example, his book, The Fabric of the Cosmos, because in it he cites some of the theoretical experiments, but they're very rigorous theoretical experiments, which were calculated by Hawking long before he died, the work on the geometry of black holes. Because what Hawking is able to do, and I will probably butcher this or certainly popularize it in a way that physicists would really want you to go back and read the actual physicists on this topic, but that he says it has to do with the amount of information that a black hole can contain. And when they've calculated that amount of information and then calculated against the pretty specific and rigorous calculations of the surface area of the black hole, they figure out that there's an absolute limited size of space to the smallness of space that can carry the amount of information that a black hole that they know it's emitting through the natural processes of entropy that we can actually experimentally verify. So there's evidence, experimental evidence behind the mathematical models that suggest that a Planck square space just doesn't get any smaller than that, which is a really interesting solution to Kant's problem of divisibility, because it doesn't suggest, these aren't things, they're not atoms that you suddenly get down to and you can't crack them any further because they're too hard. That would be the atomists' view of reality. Rather, it says below a certain level of microscopicity, it's just not making any sense to divide anymore. Division doesn't work anymore. And yet when you back out of it, you actually have space and time. So space and time have some kind of relationship to observability, to successibility, and that's the argument that I'm making, that these models, whether they're models of divisibility, whether they're models of the question of the edge of the universe, whether they're models about, like Dante gets into, try to think outside of the possibilities of the human. Why? Because Dante is trying to think of the architecture of the cosmos as planted, as created by God. He's trying to think what God would have planned. He comes up with both a beautiful model, an elegant model, and a model that solves what's kind of a scandalous problem for people in the early 14th century, which is, if you're saying that the universe is whole and self-contained, you're going to run into problems like, how can God move it? And those problems led deep thinkers like Dante and those others before him to posit modes of geometry that they didn't have the mathematics for. Yes?
Thank you, first of all, for this fascinating presentation. Thank you. In this model that you have illustrated and that we know, the hypersphere, how, in your opinion, is this compatible with the way Dante designs the action of the angels? Because it's connected to the motion of the spheres in the side of the material spheres.
Right. So it's interesting. He is very well versed in the physics of his day, namely the mechanics of his day. He's very well versed in obviously what we could call the Aristotelian notion of concentric spheres that he's using as a model. What's brilliant about the model, of course, the Empyrean sphere is the fastest. He says so in the passage that I just read. It's the fastest in the sense that it's the swiftest of sphere. Yeah, when he steps, not the Empyrean, the primo mobile, exactly. So when he steps off of the primo mobile, he points out that this is the swiftest of spheres. But what gives force to all of that motion is the motor of God's love, right? So you get the sense that the angels are circulating faster and faster and that all of that motion and that beautiful picture that I pointed from the 19th century is being generated by this vortex of desire, if you will, around the pinpoint eye of center that is God itself, God himself. This is a remarkable image, and his poetic power is such that I can still recall in studying this 20 years ago and working on this original research that I would get vertigo reading that section. Actual physical reaction, right? When he describes, he says, imagine the shiniest, tiniest point that you possibly can, the tiniest, shiniest star, as so brilliant you can't even look at it, and put that next to the point that I'm talking about, and it's going to look like a big faded moon in comparison. And you really make yourself do that, and you start to get a kind of sense of vertigo because of the power of his language. In the back, for a change.
Yes, thank you very much for your presentation. I'm just still confused that Dante, still he was a medieval thinker and he had to believe in hell. So my point, did he was a sincere believer in hell, or he just had to kind of to comply with the official doctrine? And by the way, all these concentric spheres, 9 spheres of hell, it was the then official Catholic doctrine, or he kind of made it up?
The existence of hell was official Catholic doctrine, but what Dante did was to imagine it in a way that was so powerful, so tactile, so concrete, that then that actually created, in many ways, the infernal imaginary that then existed after him. Much more vague imagery was used to describe hell, and this had been borrowed from the ancient Greeks as well. The question about the literal belief in hell or not, I think, is a very good one, because it raises the question of to what extent medieval thinkers and medieval poets would have been engaged in something along the lines of a distinction between literal and figurative belief. There have been many arguments, many good ones, I think, that distinction is a particularly modern distinction that medieval thinkers like Dante would not have felt obliged to follow. Augustine himself, who I cited here, wrote an entire book a long time ago, pointing out that the literal interpretation of the Bible made absolutely no sense. And he was writing close to or around 1,000 years earlier than Dante. So the idea of literal interpretations is really something that that we've managed to perfect in the modern age. It's a kind of anti-modernist reaction against that comes in the form of what we call fundamentalism. So there's a very funny way in which people, when describing fundamentalists today, call them medieval. That's really not very appropriate, because the medievals in many ways were far more sophisticated than religious fundamentalists are today. Yeah.
Thank you. I've read that one of the strongest indications that space and time are not fundamental is the many observations, well-established observations of quantum entanglement and non-locality. So is there any of that? Do those observations have any correlates in Dante or medieval thought?
So this is a great question. It goes to the heart. That's why I included the thought experiment from Kant and leading into as more of a teaser into quantum physics. The book that this is now going to be a part of my work on Dante largely goes in that direction as well. And yes is my answer. It does. Now, I always try to couch that with a great cautionary note, which I try to do with Dante as well. In no way does this suggest that quantum theorists and medieval theologians are talking about the same thing in that. No. Rather, what I argue is that theologians, sometimes mystics, sometimes poets like Dante, took risks and thoughts of such enormity that they pushed logical possibilities to their absolute limit, that they pushed through their attempts, like in Dante's case, to imagine the cosmos as a whole. They ran up against problems that you're going to run up against one way or the other, whether you're doing high-power experimental physics at the beginning of the 20th century, or you're thinking these profoundly difficult, theologically inspired thoughts in the Middle Ages. And it is precisely that issue, the issue about how does an observer ensconced in certain kind of forms, temporal and spatial forms, in fact, observe a world that itself may not respond to those same laws. Right? That's the exact same question in a different formulation that the medieval theologians are asking themselves, because, of course, they are positing a God who does not respond to the dictates of space and time, by definition. If you're omniscient and if you're omnipotent, right, you, in fact, know everything from beginning to end. That raises questions about free will and causality. These questions are, in fact, the same ones that questions of entanglement, questions of the collapse of the wave function are, in very interesting ways, engaging with. Mm-hmm.
Thank you.
Oh, back there.
I had a question of what your opinion would be on the idea that evolution has only equipped us to know what's needed for survival, and that in people like Dante and the scientists, that there's a mutation that they have, like an appendix that's not necessary for survival.
Well, look, evolution, any evolutionary biologist would tell you, evolution never just equips a species for survival. Your species are selected the way they are in the present through natural selection, but all sorts of non-essential to survival mutations take place. There's huge arguments in favor that so much of what we do with our brains is in fact completely accidental and inessential, and yet the excesses of the Homo sapiens brain have produced everything that I and my colleagues in the field of humanities spend our lives studying. And certainly one can make a huge argument, a very important one, that sure, if Occam's razor were just survivability, we wouldn't have any of this, but we have it. Yeah. Yes, in the front.
Planck square is named after Max Planck?
Yes, yes.
How small is it, and why can't it be divided? How do you?
Well,
how
so
do you-
that goes back to your question before, and I can see you're absolutely fascinated with very good reason with this idea. The Planck square is what comes out of the equations that Hawking ran on the surface, measuring entropy theoretically, calculating what the minimum surface per information unit coming out of a black hole would be. That's where, amazingly, this number that has a relationship to Planck's constant came out. And when you ask the question of how small it is, I mean, let me give you an example. If you go in the other direction, the number of electrons in the universe is probably along the lines of 10 to the 80. Okay? So now you go in the other direction to smallness. I mean, we're getting that small. So if we're on the level of ones and tens, 10 to the negative 60 is, boy, are we getting small.
So it's an exponential square, not a geometric square. I hate to be pushy about this. But
Yeah, no, it's 10 to the, what he's talking about is, yes, it is a surface, it is a surface area, the length of a square of, it's square, it's that many meters to the negative, it's in meters, that many meters to the negative 10 to the negative 60th or 66th, whatever I said. Yeah, that's the calculation that came out. But the answer is unimaginably small. All right. Okay, yeah? All right. Thank you, everybody. Thanks for coming out. Thank you, Allison.